So in these last 3 weeks, we are going to be doing a lot in H2O. So I really recommend that you take a lot of time out this week to get used to it. First of all, I recommend that you read the Python booklet, which I've got the link for you there, at least till the machine learning bit. I'm not sure I would bother reading the machine learning bit just yet. We'll cover some of that together, and then you might find it easier to read it afterwards. The second thing I recommend you have a look at is Amy Wang's tutorial. I've again given you the link, but let's get going. Import pandas and h2o and print the version. Now this is really sad. The version in here is a year out of date. Niels is updating this, and I hope even within the next week or two before you do your final coursework, we'll all be able to be using the same up-to-date version. Now, I have started H2O, and therefore I can simply connect to it, although that is clearly not the right thing to connect to. Right, so that's my IP, you'll have your own IP. And that was straight away, it's immediately connected our Python session to that Java virtual machine. By the way, can I just say, do you know how crazy this all is? We're running a Google virtual machine. So somewhere in a warehouse full of Google machines, we've carved out a bit of space in a machine which you are logging into through your browser. Inside of that virtual machine, we are using a Docker image stroke container to create for us a virtual machine in that virtual machine. And finally, inside of that container, we've now created a Java virtual machine which is running H2O for us. So we're basically 3 deep inside of a machine. So when I find it hard to get my browser to connect all the way through to the middle of that, I'm not always completely surprised. Anyway, if you didn't bother trying to follow the hard way of starting Java, when you did connect here, you would have just got a load of error messages. And the really good news is that all you actually need to do, if you're not worried about that pretty point-and-click interface, which we will have a look at together afterwards, the only thing you need to do is h2o init, which will actually start the machine for you. This was already started, but it didn't give you an error message. It just said, fine, I'll connect if you want me to. If we want to shut the cluster down, or the Java virtual machine down, all we need to do is run h2o.cluster.shutdown, but we're not, because there's not much point doing that just yet. We are going to create a data frame, which we do with that. Finally, now we can get going. What are we going to do? Well, we've got that Java virtual machine. If we want it to do any work on data for us, we have to send it the data. That's kind of fairly obvious. And the way to send it the data, if it's a data frame, is just h2o.h2o-frame df_all. Yeah, the data is now in your Java virtual machine. I'm going to send the same data exactly again. Good, it's been sent. So where is the data? Well, if you're used to Linux or even R, the ls command will list the contents of a directory. So h2o have given us h2o.ls to list the objects inside of h2o, our h2o virtual machine. Let's see what there is. Well, there are 2 objects there. What has happened is that every time we sent this data, it didn't know we were sending it the same data. It just thought, the Java virtual machine thought, here comes some data, I'd best store it. So it stored this one, it stored that one. We didn't give it a name, so the poor machine had to make up a name, and you can see it's made up a very long name. Now, this looks a little bit like a data frame. It is a data frame. Let's have a look. What is the type of it? It's a data frame. What is happening when we run this is that we are sending a message, some kind of HTML message, to our Java virtual machine, asking it to list all the objects. It lists all the objects, and because it knows we are coming from Python, it returns it to us in a way that Python can print it out prettily, which in this particular case happens to be a data frame. Now, let's say we want to get the data frame back from h2o. Well, what we have to do is, unsurprisingly, use the h2o getFrame command. There we are, we got it back, and let's just have a look at what that actually is, the thing we got back. Phew, it's a data frame, which is just as well. Now, how do we go about deleting all the frames that we've just sent to the h2o Java virtual machine? Well, here's the data frame of all of the frames, keyframes. We can print each of them just by iterating through that. We've talked enough about how we iterate through things. And instead of iterating it through it and just printing it, how about we actually remove that thing each time? So h2o.remove, unsurprisingly, is going to remove an object from your Java virtual machine. By the way, in case I forget to say this afterwards, just like you don't want to keep your Google virtual machine running because it will cost you, you don't want to keep your Java virtual machine running because, at the very least, it takes for itself as much memory as you allow it to use up. So if you've set aside 1 gig of RAM for it, it's going to be hogging that for itself, and you won't be able to do other things that you might want to do. Now, let's send the data to the JVM, and instead of being silent about what we want it to be called, we'll give it a name. So the name of our data frame is dfall. Why don't we call it dfall in our Java virtual machine? Why not? We've passed it to it. Now let's have a look at the objects in our Java virtual machine, and we have an object called dfall. It's much easier to get the frame. It's much easier to remove the frame because we've got a name for it. Now, it's one thing having the data frame in your Java virtual machine stored as this frame kind of thing in your virtual machine, but sometimes you want to do things to that frame whilst it's in the Java machine. So you've sent your data to the Java machine. Now imagine you've sent 5 million records to the Java virtual machine and you realize you want to add 2 columns together. Well, you have a choice. You can take it all the way back to here into Python and use pandas to add 2 columns together, or you can send a message to your Java virtual machine telling it to add 2 columns together. Now, it can be convenient to send messages by having a handle to refer to your data with. So what we're doing here is we're just creating a handle to that data. And the nice thing about it is that now we've got this thing which points to your h2o frame. They've given us some methods which should look very familiar, but don't be lulled into a false sense of security thinking this is doing anything at all in your Python session, because it isn't. When you do dot shape here, you are using methods provided to you by the h2o team, and those methods are working in your Java virtual machine, and if you get anything back here, it's because after doing the work in the Java virtual machine, it is sending a message back here. So that 3.3 arrived at you in a very complicated way. Let's remove it and start again.